Physics, polarization, reflection, and refraction. So for this example, we have sunlight being reflected off of the surface of a calm lake. Alright, so part A. What is the angle between the sun and the horizon when the polarization is the largest? B. What is the reflection angle? And C. What is the angle of refraction in the water? So the first thing that we should do is, as always, draw a picture of what is happening. So down here we have the surface of the water, and then we have an incoming ray of sunshine, and that is hitting the water, and the angle between that ray and the water or the horizon is basically, we're just going to call that theta 1. Then that ray of light is coming down and hitting the water, and the light is being reflected away, and so the reflection ray is going off at an angle of basically theta p. So we're just going to call that theta polarized. And then part of the light also goes into the water, and it is refracted by the surface, and so that goes off into the water at theta 2. So we have 3 different thetas. We do know that we are dealing with water and air, so for our given information, we know that we have in water is equal to 1.33, and you can add more digits if you like, and then N sub A, or in air, is equal to 1.00. So with that, to calculate theta 1, we would need to use, before we do that, our unknowns. We need to find theta 1. We need from part A. Part B is we're looking for theta p, and part C we're looking for theta 2. So those are all our unknowns. Okay, now for finding theta 1, the angle between the sun and the horizon. Theta 1 is basically going to be the complement of the mathematical complement of your of theta p. So theta 1 is going to be equal to 90 degrees minus theta p. So we know that, and then to find theta p, the polarization angle, we're going to have to do the tangent inverse of N2 over N1, which is, in this case, going to be your tangent inverse of N sub W, so the water over the air. So over in the theta p, the N sub 1 was the material that the light was in to start with, and then N sub 2 was the material that the light is coming in contact with. So in this case, yeah, tan inverse of N sub W over N sub A. Alright, so when we plug in numbers into that, which we can do, we end up with tan inverse of 1.33 divided by 1, which is going to be equal to 53.1 degrees. And this is actually the answer to part B. Alright, and then Moving on, so back up to the theta 1 equation, we have theta 1 is equal to 90 degrees minus theta p, which is the 53.1 degrees. And so theta 1 equals 36.9 degrees. Alright, and then finally, we have to find the angle of refraction. And so to find the angle of refraction, we use a pretty generic formula, which is sine theta 2 is equal to N1 sine theta p divided by N sub 2. So for this problem, we can go ahead and keep it in the form of its variables and go ahead and solve for theta 2. So theta 2 is equal to the sine inverse of NA, or so N sub air, sine theta p divided by N sub w. Then going ahead to plug stuff in, theta 2 is equal to sine inverse of 1 times sine of theta p, which is 53.1, all divided by 1.33. Interestingly enough, when you solve that, you end up with 36.9 degrees is equal to theta 2. To be noticed here is that theta 1 and theta 2 are equal. And this has to do with basically finding the angle at which the light is going to be the most polarized. Means that there's not going to be any sort of, the refraction angle is going to be equal to the angle of incidence. And so overall your theta 1 is going to be equal to theta 2. At any other angle other than what was given, there would be a refraction, and your angle of incidence and your angle of refraction would be different.